All right, good afternoon, everyone, and thank you so much for joining the seminar series today, especially today because we are right around the corner for starting of the fall semester. So I really appreciate you being here. So before further ado, let me quickly get back to a quick overview of myself. I'm a networking person. I've been working on wireless networking research for the last 2 decades now. In the last few years, we have shifted our efforts towards a little bit more towards the Internet of Things, within that smart healthcare, smart home, augmented reality. And in fact, those are the projects that I'm actually going to share with you today. I'm also very much interested in actually increasing the recruitment and retention of the women and minorities in computer science. And I have been working towards that goal ever since I've joined UCF. From the teaching angle, I teach software engineering and computer networking courses at the undergraduate and graduate level. And as you can see from my slides here, I am quite active within my professional service through various professional service activities. And I also, I think, greatly contribute to outreach activities within UCF and outside. Okay, so today the very first research direction I would like to share with you today is the IoT Smart Healthcare. So you all have heard about the Internet of Things, and many of you own some IoT devices in your homes, like smart light bulbs, plugs, locks, fridges, fitness, and so on. What exactly we define as IoT is a bit messy sometimes, but essentially what it really means is that we have a lot of inexpensive network-connected computing devices, sensors, actuators all around us, right? So essentially, if you have an elderly or a disabled patient, today we can easily deploy a lot of inexpensive sensors to their home environments, actually, right? We can put them around the house, we can put them under chairs, walkers, under the floor, ceilings, medicine cabinets, and you name it. So that basically creates us a lot of data, but the data is noisy. So essentially, we need to develop software and use machine learning and AI to make some sense of that data that is being collected. So let me illustrate this with our smart walker for the elderly and rehabilitation. In fact, I just want to say that this was also a multidisciplinary collaboration. The original idea came from Dr. Ross's group at College of Medicine. Basically, this was assembled by students from mechanical engineering and electrical engineering department. So from the computer science perspective, we ended up providing a software, and in a different project, we added some AI functionality, which included things like predicting the falls. Okay, so the walker essentially is a very low-tech assistive device, which is used by elderly or for rehabilitating a person with a leg injury, let's say. So the idea is to take a regular walker and augment it with IoT sensors. And as you can see from the picture here, that we have lots of sensors. We have weight sensors, we have proximity sensors, all connected through the Raspberry Pi with a user interface. And so let us say that you have a person with a leg trauma, and the physical therapist instructed him how much weight he should put on a different legs, right? But usually doctors have a hunch that the patients may not follow the prescription exactly. But with the smart walker, we could actually verify that whether the person actually followed the prescription correctly, right? So, so what we did was we basically turned off the user interface, but recorded the weights put on the legs, and basically you get what you see on the left side of the figure, right? And so the patient was definitely trying to follow and putting the right amount of weight in the right leg, but the values were definitely not that great. They were way off. So essentially what this means is that his muscle memory simply wasn't helping him, right? But if you look at the figure on the right, the numbers are actually much better, right? So here we use the smart walker's user interface, which actually gave feedback to the patient to see if he should put more or less weight on a given part of the walker, right? So if you think about this, this is a really very simple application of IoT, but it can really make a big difference in a person's life. So, so right now we're also working on different walkers with cameras specifically designed for visually impaired person, navigate within their environment, and a number of other applications which involves more sophisticated things like AI and predicting the falls and so on and so forth. All right. So quickly moving on to the second project. So here we have a project involved with the scale tone. So now the question is, why do we need something like this, right? So let us say that your home has a bunch of IoT devices, as we mentioned earlier, and you can also assume that you can remotely control each of them with, let's say, Amazon Alexa, right? But does that really mean your home is smarter than before? Does that mean you're more comfortable than before? Does that mean you're getting better energy efficiency, lower cost, or is your home is much greener, and so on and so forth, right? But the reality, the answer to those questions is that we really don't know exactly, right? So, so it's just simply not enough to remotely control IoT devices, but the idea is that you also need to make some smart decisions, right? So, and some of the decisions will have more, long-term effects. Like for instance, is it better to install a solar roof or a plant shading tree next to your apartment, next to your home, right? To lower your temperatures, but you can't really try both of them, right? So our idea is that it is really difficult to make real experimentation since experimenting with various home configurations is generally very expensive. So our scaled home, as you can see, I have two versions here. We have scaled home 1 and 2. Version 2 is being the latest one, is essentially a reconfigurable model of a suburban home. It has sensors in every room, and it captures temperature, humidity, and light. It has actuators to remotely opening and closing of the doors, windows, and shutters. And I don't know if you can see from the figure, but we also have the environmental enclosure to model the weather. So you can basically see that our scaled home is modeling various smart home and smart grid scenarios under various weather conditions, and we can also have human in the loop user behaviors, right? And the best part of it all is that we can do this remotely. And so we actually had a guest student from Italy who actually unfortunately had to leave early to go back home due to COVID. But actually he finished his master's project by running the experiments remotely, sitting in his apartment in Bologna, modeling the weather in Milan on the scaled home in our lab in Orlando. So if you look at the figures here on the right, so what you see on those graphs is essentially how the weather modeling is tracking a particular day weather in Milan. So I think that's really pretty cool. So you basically are going to see a lot more of these type of experimentation coming out of our lab. All right, moving on, the last project is the predictive caching for AR experiences. I think, yeah, we all agree when I say augmented reality is absolutely fascinating topic, and that there's a vision of the future in which we're going to be continuously surrounded by AR, experiences. So, but the problem here is that realistically, these experiences really need to be served from the cloud. So the question is that can you serve AR from the cloud, right? Because it requires a lot of data, and not only that, the data needs to have a low latency. Because if your AR VR experience actually not at par, it's lagging behind, you're going to have issues like headaches, and you might even throw up. But the reality is that frankly, no one really has this kind of super low latency internet connection, right? So then if that's the case, then we have to find different solutions. So one way to solve this is to cache the data very close to where it will be used, right? Traditional caching, the type we're using for the processor cache or file systems, are really not too much help here, because very likely each piece of information will be accessed only once, not multiple times, right? So in that way, we can say that this really fits within more into the topics of content-centric or information-centric networking as well, right? So basically, we need to predict what the user wants to watch, when, and preemptively cache that information, right? So and how do we do that? Of course, it's not easy, and it's also scenario dependent, right? But let's say that you consider a home user here, right? So if you know that you will have an access the weather report at, let's say, 8:15 a.m. in the morning, we can preemptively download it for you, right? And the more precise our prediction is, then we can afford to download it at a higher resolution. A higher resolution, of course, should be the better, right? And the overall goal is essentially to improve your AR quality of experience by better prediction and by more clever caching algorithms, essentially, right? So to that extent, what we did here, we have designed several algorithms and we've trained them on real-world data sets. And I'm sorry to say that there are actually very few real-world data sets on human behavior. This is actually a very much an ongoing problem for us. Although we hope that we can potentially solve the problem with our scale home by generating realistic data, right? Okay, so basically what you need to do here is that you have to have caching algorithms that you don't depend on prediction, which is fine. But in that case, you can try to cache everything, but that also comes with a price, right? Because you're not going to be able to, use that data multiple times. But then you can only, if you do cache everything, then you can only afford to do this essentially with a very low resolution. So alternatively, you can assume that you have an oracle, right? Which basically tells you exactly what the user still wants to access, right? But of course, having oracle is just simply not practical. And so, but it is a good metrics for us because it tells us, what is achievable with this work, right? And so through our algorithms, it turned out that deep neural network, that so-called long short-term memory, LSTM, I think most of you are familiar with that, essentially outperformed all the other protocols. When I say all the other protocols, except Oracle, of course, because we need to, and if you use a probabilistic model, it can potentially also help us as well. Okay. And so quickly, my near-term plans are basically continuing on, adding, further, improvements to our ongoing projects. I'm happy to participate in interdisciplinary projects that needs things like networking, IoT, cloud, edge, sensor, and whatnot. In the long term, I'm happy to look to see our UCF campus more smarter, more greener, and using more, extensive IoT technologies and using renewable energy sources. And I would also be very much happy to go for larger center grants through collaborations of the faculty or local industry. And lastly, but not least, I would love to continue my efforts in broadening participation in computing to increase recruitment and retention in computer science for women and underrepresented minorities. So with that, I will conclude my talk. Thank you.